unfortunately, my slides are cooked off the right side. I tried everything, so just try and tolerate that. Basically, just to briefly introduce myself, my name's Nathan Monson. I've been coming 3 times a month to this club for about a year now. Actually, the first time I started coming regularly was in January, and it was after robo development. I found that really inspirational when I went and watched last year. You know, so I'm coming along, building my first robots, and you know, sort of has been a great opportunity to meet all you guys and all that. So thanks very much for everything you guys have done for me. One thing I'm curious about is just how many of you guys consider yourselves better at software than hardware? All right. And how about the other way around? You're better at hardware than software. Okay. All right. Well, it looks like we got a mix then. Well, you have to be good at both to build a robot, of course. But I actually think that the BeagleBoard has benefits to both groups of people, because if you're a real software nut, then the BeagleBoard is great because it's a very expansive platform you can use. Whereas if you're a hardware nut, it's actually great because it's really you can run a lot of really easy to use programming languages on it, and it's considerably easier to work with than something like, you know, a propeller or a pick or something like that. I don't know about you guys, but I mostly come to the club for show and tell and random access. So I actually wanted to start with some show and tell. Tony, would you like to show your Beagle Bot for the club?
So what I'm doing now is I'm getting into the commands. When I type them in the console, cause the robot to do something. This is an example of a robot that originally did not have. We're going to do the demo here.
If there's any way you can like walk it over here, maybe with some help. If you guys mind scoot over. And this is a robot that was originally built around Bob and Ted's RoboBricks pick-based infrastructure, and he's actually added the. I'm sorry.
I'm actually going to go around this way so I can do some stuff on the floor.
Oh yeah, that's probably safer with the robot.
It'll take off.
He's actually added a Beagle board to be the main processor.
So the main item here is that we have this is a robot that started off being pick-based. Now we've added a BeagleBoard to it, such as that if you have robots, right, you don't have to build a whole new robot to get the BeagleBoard working. If you get it. We took the debug serial port on the BeagleBoard and plugged it into the PIC. Watch out because it's TTL versus RS-232, so you could, so watch out if you're going to do that.
You need a little level converter or something like that.
Okay, now we're going to try and go forward here.
So what you're doing here is you're sending commands to the BeagleBoard, and then the BeagleBoard's sending them on to your nervous system, right? All right.
Here we go. First BeagleBoard, the first steps of getting the BeagleBoard to control the robot.
Yes. So you can move and, all right.
I can also get the compass. You can't see it, but I can get the compass bearing from the BeagleBoard too.
All right. So it's bidirectional.
Yes, so it's bidirectional.
And when Tony was showing this to me earlier, he was also getting GPS coordinates, although it probably doesn't work as well in here. And one of the funny things that was, for me, was when Tony first got the BeagleBoard working, within a couple of hours, he found a bug in the PIC stack that he'd never seen or he'd never understood before, just because having a higher level board with more robust you know, tools and all of that helps you gain much more visibility into what your code's actually doing. And I guess that bug might have caused a few false turns and
some very interesting
behaviors.
Yes, we're dropping a digit of the GPS input.
Right.
So.
And this is a Robo Magellan bot, so.
Yes. Yeah. Our hope is that with BeagleBoard we can get cameras and stereo and all that good stuff going on there too.
Right. All right. So this is Tony's Beagle Bot, and it's now moving. So do you want to give us a show, Rob?
Do you want to bring up
Tony,
where your slides are?
what do the logs mean?
Oh, sure,
Behind your
absolutely.
name. Cataglyphis, Bicolor.
Oh, it's an ant. Yes.
Someone knows. Yes. It's a type of ant. So actually, while Ralph sets up here,
Destroys the place.
it's all right. Just don't knock over any robots. And we're good.
Pull up the stuff.
Oh, you bumped the. Is there any way we could like readjust this really quick? That's perfect. Okay, so let me just go on and talk about my robot. And so this is Snappy, and he's actually been in progress for about 9 months now. And this was an earlier. Oh, sorry. This was an earlier version of Snappy. Actually, as you can see, he's got like this acrylic base that goes all the way from his wheels to his shoulders, whereas the version that's right here is just sort of like a spine. And one of the reasons he has this big, long acrylic base in the old model was that I was using it to support one of these motherboards. And this isn't quite a Pico, our Pico ITX motherboard, like or Nano ITX, I guess, which is what you guys have gotten. Nano ITX is a little smaller, but it was a similar idea. And I got to say that building your robot around a PC is definitely the way to go. For all the reasons we'll talk about with the BeagleBoard. The BeagleBoard's very PC-like. And the only advantage the BeagleBoard has over something like this is lower power consumption. As you can see, I had to mount some fans on heat sinks on this guy, and it actually consumed so much power that the batteries would last like 70 minutes, and it would burn you if you picked it up in the wrong spot. So it's kind of dangerous. And the other thing is he needed major batteries. Actually, about half his weight was batteries and the motherboard and heat sinks and all the metal and fans and all of that. One of the disadvantages I learned along the way about building your robot out of acrylic is that it can actually shatter like glass. So Snappy lived up to his name and unfortunately fell over one day and snapped into about 9 pieces. So this is all that remains of the old Snappy. So I decided to go ahead and try and seek out a better controller that was maybe lighter weight, that would allow me to use a smaller battery and all of that. So I went ahead and switched to the BeagleBoard. I'll talk more about how the BeagleBoard saves power, but one thing that's great about it is that I now have half the batteries that I had on the old Snappy, and instead of lasting 70 minutes, it lasts 12 hours. So I can basically work on the robot like all weekend long and then like charge it up for the next weekend, which is pretty great. Now, one thing that a lot of people are interested in with these robots is some sort of camera interface or some sort of vision processing. So what I wanted to do was just a really brief demo of what I've been able to do with the vision processing. I'm using the S-Video port on the BeagleBoard, and one of the nice things is that when you're doing vision development and the like, if you're doing it on a microcontroller or something, it can actually be hard to get the process data out in a form you can see, like across a RS-232 or something like that that's really slow. Whereas if you're doing real-time processing, what you'd like to be able to do is actually see what the camera's seeing. And so, by the way, you're sideways because the camera's sideways, and there's a reason for that I won't bore you with. But you can see that, like, you can easily stream camera feeds out through the S-Video. Now, to give you a little demo of what I've got running, this is just the Sobel edge filter, and I'm sorry it's kind of dim. I'm not exactly sure why, but yeah, you can see this is real time. And actually, if I go around and walk in front of it, or wave my hand or whatever, that effect is not working very well on this projector, I'm afraid to say. But yeah, you can see it's actually doing all the edge filtering, finding edges and all of that. One thing about this is this is real time, and it's got no problem keeping up with 640 by 480 at 30 frames a second. And the other interesting thing is that on the BeagleBoard, you can do this sort of processing while using 0% of the main CPU. And I'll talk a little bit more about how that's possible later on in the presentation. But like I say, it's a real benefit to be able to run your vision kernels and then just like actually see what the input is and the steps along the output and all of that in real time. And that's what the S-Video port lets you do. And if you don't want to use the S-Video port, there's also an HDMI port that'll do 1920 by 1080, and you can hook it into a big fancy TV set or whatever.
Can you explain what is the camera's pointing, and I'm seeing that something that looks a little bit circular near the top section?
Yeah, actually.
What is that from?
What that is that's the light right here. And actually, the edge filtering is not perfect, and what it's saying is it's saying this is a shape.
Oh, so, just a shadow.
Right, absolutely. And there's ways you can work with that, of course. That's part of the fun of using these
so it's not an
filtering
algorithm.
algorithms.
It's real. There's something after to see.
Yeah, exactly.
It's more than what we would actually see.
Right. Well, we're better at it, but we have more practice. So, all right. So you ready to get this little shot?
It's just okay. Starting up right.
All right. Okay.
There we go. Do you want to plug the video?
Oh,
projector
absolutely.
in
So
here?
why don't we show what you've got going on your Beagle Bot?
This has some interesting outputs. That doesn't crash everything now, trying to.
Oh, we're gonna have to do one day. There we are. That's you. Oh, so close.
Do you know what the resolutions of that?
Yeah, it's a 800 by 600.
Is that all? Okay. Change my.
Okay, so yeah, so another thing that was really nice about the BeagleBoard was I was using the PC before, and I've been running Linux as my main controller, and using some open source software like PlayerStage and libkdl to help organize the architecture of my robot, and all of that ported over to the BeagleBoard very easily. So if you do start out on one of these Nano ITX boards and later you want to move over to the BeagleBoard, it's actually a very easy thing to do because the BeagleBoard's very PC-like. All right.
Okay, so hopefully I can now show you an alternative BeagleBoard. This one is a Roomba-based one, and you can see here it also has a camera on it. So I'll just try to tweak a few things. What I've been focusing on with mine is just with the OpenCV and some camera calibration ability. As you see within the video here, I have a little scale that doesn't show up particularly well on the video, but once the camera is calibrated, and you see I have a target frame for the OpenCV fans that if I put that down in front of it, I then have a routine where the robot will actually take a sequence of images from different positions. It drives itself around, grabs that, will auto-calibrate, but that's kind of breaking right now. But once I've done that, I can just double-click on the image, in theory. Software.
And this is something else I've observed is that the one disadvantage of working with these more sophisticated PC bots is you start running into problems like, my robot doesn't have an IP address, it can't move, and things, problems you just don't have with smaller, simpler robots, right?
Where's my
And so-
DNS number?
Yeah, exactly. So there's a price of the complexity too. But if you're doing research, it's really the way to go because you can use so much open source software to assist you. And Ralph here has been using OpenCV to do a lot of his vision processing. Sure, go ahead. Yeah, absolutely. Yeah.
What's the core processor on BeagleBoard?
Yeah. There's another slide with all that information, of course, but it's a 600 megahertz, and it's actually an ARM Cortex A8, and that's the very newest ARM processor. In fact, it's still in engineering silicon. So one of the interesting things about the BeagleBoard is TI has been producing it to help work the bugs out of their system, for free using hobbyists like us. But I don't want to intimidate you. It's quite stable silicon, but it's also very, very cutting edge. This is the sort of thing you'll find in cell phones next year.
Is that an ARM with a floating point?
Yes, in fact, it's got a very powerful floating point unit. It's capable of 2.4 gigaflops, and so substantially more powerful than like previous ARM processors. It's very akin to like a Pentium 3 or something like that because it has simmed instructions that are very similar and all of that. So.
Okay,
All right,
I
great.
think I just got control back. Yes, it's talking, so I can run the Roomba up now, and the video hasn't died on me. One thing talks and then the other bit doesn't talk. And, I can go quickly over what the bot has. It's the basic Roomba with the BeagleBoard mounted on it. And I have a PIC-based controller that talks to the Roomba via the serial interface. There's various infrared sensors that it talks to, then that talks via USB to the BeagleBoard. The BeagleBoard's also driving a wireless interface and the camera. So then most of what I do, I just stream the command and telemetry back to an application on the desktop, and the video comes back to the desktop. And that way I control it all using the desktop software, which is that communications, which of course is giving me problems. The camera as well. Sorry about this, Nathan.
No, that's fine. What's power consumption on the Beagle? It's about 2 watts running full out. It's usually closer to 1 watt if you disable the features and run power saving modes and all of that stuff. So
Is the documentation that comes with that pretty good?
yeah, it's actually at various levels. The one great thing about the BeagleBoard is it has good community support. So there are wikis and forums and IRC chat and all of that to answer questions. But the other thing is that TI has gone overboard. The reference manual is 4,000 pages. So, but you don't have to read all 4,000. It's actually nicely tiered in terms of summaries, and then you go to detailed sections and all of that stuff.
Is the instruction set of the processor documented also in some of
Absolutely,
it?
yeah, and that's documented by ARM because the Cortex A8 is a really important core for them. It's their first step into really PC competitive performance.
I asked because I was working with a Cortex something 3 M3, I guess it's called, and I had a hard time finding
Yeah,
the instruction set documentation for that.
yeah, that hasn't been a problem for me. So, sorry, go ahead.
The BeagleBoard has got a USB interface and then some expansion headers.
Yes.
The robots you've shown, is everything done through the serial port or a USB port, or are you using any of the other expansion?
No one's, to my knowledge, is using the expansion headers for a robot yet, and one of the reasons for that is that the expansion headers are 1.8 volt, so you need to design something that includes level conversion to interface with most boards. The expansion headers are nice, though. I mean, they have things like SPI and I2C and all of that stuff, and the kernel has good support for that, but I know I don't want to put you on the spot, but I know Dave has mentioned he's interested in the idea of maybe building a daughter board at some point. So
yeah, I guess the comment there is I've spent a fair amount of time looking at the hardware reference manual, and what I was thinking of doing is just building a very simple adapter that takes that expansion port and brings it out so that it talks to the RoboBricks bus and look at, it's basically, level converter chip and the CAN transceiver logic and so forth. Wouldn't really be too hard to do something like that in theory. So
right, and obviously it'd be something that I think a lot of people could take advantage of. So.
Okay.
Hey, all right.
A couple of seconds, I have some video back, so now.
Okay.
So as I was saying, in theory, I should just double click on the image. Let me get it to just do something basic to start with.
All right.
So now you see I kind of pointed.
Click the destination and it drives to the destination. That's quite impressive.
I mean, if it's calibrated, it works really pretty well.
Right.
You put something on the floor and I can turn it and ride and stop right up.
Right.
So as well as that, because you can't see things, I've just got this little interface, so I click on that and it'll just rotate by a certain number of degrees.
This is really quite lower latency than most of the telepresence robots I've seen. I mean, it's very responsive in terms of the video feed showing.
So that's the basic what I've been doing with the video so far. The other things I've done with the robot, and unfortunately the quality here is not that big, and for the Roomba fans, this is basically all the telemetry on the left-right bumpers, the wheel drops, and all the sensors that the Roomba has comes there. I can look at the power and voltage within the Roomba telemetry, comes out here. I can control it. It's still a working Roomba Discovery with all the vacuum motors controllable there.
Does your wife appreciate that? Yeah.
We can flash all the lights and all that sort of stuff. You probably can't see that very well there, but we have that. What I also have mounted on here, they're powered up and working. And that's where my software stops usually.
At least you got through the best.
So you've seen it move. So I think I'll let.
All right. Yeah.
The other things I was going to quickly show, I have infrared sensors on a scanner. I have an overlay on a 2D map where I'm trying to now work on tracking, where you can see the sensor scans overlaid onto a map and I'm even working on 3D reconstruction of poses and stuff like that.
This is kind of a
So-
cool tiered system in my opinion, because you've got the Roomba controller on the bottom, and then you built a custom controller.
That there's 4 or 5 layers.
Beagle
in here.
boards on top of that, and then of course you have a really nice software interface on the on Windows to help navigate.
Yeah,
So-
and for all the Linux zealot, this is all .NET.
Yeah,
On the
yeah.
client side, it's all .NET.
All right.
That's a communication problem.
Thanks a lot. That's awesome. Thank you. All right. That was great. All right. Let me see if we got video. Screens. Oh, no signal. Oh, there we go. Let's get it on. Okay. Sorry, this projector is just a little tiny bit finicky. There we go. Much better. All right. That looks great. Yeah, I think you're right about that. All right, so let me keep talking.
It's like 7 years of history.
Yeah, I'm impressed by the amount of difficulty this thing's caused, but yeah. So my advice to you is, if you ever give a presentation, then don't share laptops. So actually, I did bring a BeagleBoard if you guys want to take a look at it. And while my computer's rebooting for a second, you should be back online in about 1 minute. Another thing that we're saying about the BeagleBoard is that there's a number of other people getting into this business. I mean, the BeagleBoard's based on an OMAP 3 processor, which is a very exciting product from TI. And some of you who are into Gumstix and or cell phone technology, or those Nokia tablets or whatever, might be familiar with the OMAP series. That's actually been like very successful, high power ARM processor, and this really takes it kind of the next level. Since it's designed for cell phones, it's very low power consumption. Oh, that looks so much better. Well, maybe not. All right. It's a good question. I've been asking that myself.
Why is that what?
There we go. It's already looking much better. All right. Thank you. I should be able to get this going in just 1 second. And don't worry, it's a short presentation. With any luck, I'll still be finished within 30 minutes. So. Yeah, this could also be a moral on why you shouldn't use open source to do your presentation, because I've done my share of PowerPoints in the day, and it's never been this exciting. All right. In fact, the nose isn't even cut off, so it all paid off in the end. Thank you very much for being patient, guys. Thank you. All right. Much better. Yeah, absolutely.
Yeah,
Just
I
takes. Okay. Good. You got it. Anyway, basically I'm going to do a quick overview of the BeagleBoard, and we actually talked about a lot of this already. And then I'll talk about some of the reasons that we're seeing a lot of Beagle bots. And then I'll also talk about strategies you can use to get it onto a new robot, and kind of what I've found in terms of interfacing and what the notches are and all of that. So the BeagleBoard is a PC-like embedded computer. It's 3 by 3 inches. It's extremely small. One of the issues with it, or limitations I guess you could say, is that you need to bring your own USB peripherals for most stuff. So whereas a robot like Tony's actually does quite well with no USB peripherals at all, because he interfaced it via serial. Robots like mine and Ralph's actually end up having cameras and Wi-Fi and all of that kind of stuff, and none of those interfaces are built in. What it does have is a USB host port, and what that allows you to do is plug in just about anything you can go get at Fry's. One of the reasons it's only $149 is it's the OMAP 3 evaluation kit, and so TI would like you to try out their new processor and give them feedback and all that nice stuff, but you obviously don't have to. Power consumption is under 2 watts, as we discussed. These are the hardware specs briefly. These slides will be online, so you can get all the great details when you want to. One of the cool things about this chip, in my opinion, is this tiny little chip right here has all of this stuff. It has a 600 megahertz Cortex-A8, like I talked about. Neon is actually like Intel SSE. It's a very powerful floating point unit. It has level 1 and level 2 cache, so you can see this is getting more like a PC processor. It also has a high-speed DSP. It runs at 430 megahertz, and that's what I was alluding to earlier when I was saying certain types of signal processing tasks can be done without using the CPU at all. The DSP runs independently. It runs its own operating system. You could even put like a completely separate robot controller on the DSP if that's what you wanted to do, and then dedicate the ARM to running Linux for high-level control or whatever. It also has a DirectX 10 compatible graphics processing unit. So I'm not sure how useful this is for robotics, but if you're getting into things like pixel shaders to do image processing, then this is actually pixel compatible with pixel shaders. So you can use that kind of technology with this chip. Probably the coolest thing in my
I have seen, I think it was ATI published examples of running the canny edge detectors and so Bell algorithms written as pixel shaders on a DirectX video card.
Absolutely. And one of the cool things about this guy is it's kind of untapped right now, but it significantly increases the floating point power of the machine. So sort of like you can use this DSP to help you with the integer manipulation, you could potentially use this to help you with floating point processing as well. Anything that's easy to parallelize. It has quite a few floating point units. So. Finally, the other thing that I think is cool about this is it has 128 megabytes of RAM and 256 megs of flash. And remember, that's all on that one chip. So it's a very, very integrated system on a chip. In fact, it's the complete system is that little guy right there. In terms of peripherals, it has the HDMI out, like I mentioned. That's also DVI-D or compatible in case you have a monitor that uses that. It has an SDIO card. One neat thing about this card slot is people have been plugging like Wi-Fi adapter cards and things like that into it. So this can actually support more than just basic memory, but it's also a good place to put your file system or whatever. As S-Video, it has USB 2.0, both host and device. There's a bunch of other miscellaneous stuff. These LEDs, you can control their GPIO. It has a couple of buttons that you can control. It also has, on the expansion header, someone asked about this, it has I2C, I2S, and SPI, only it's 1.8 volt. It has a JTAG connector if you want to really get into the chip and do some serious debugging. I haven't done that yet. But it also has stereo in and out, which is useful for some applications. If you want to do speech output or input, then that's a great place to do it. And obviously it has the RS-232 serial.
So I just, you kind of jumped right over the JTAG debugging.
Yeah, I did.
Correct me if I'm wrong, but I think that's ARM is a well-documented, well-known.
Yes.
So aren't the actual debuggers relatively cheap? You can
yes, you can get cheap debuggers. There's even a free debugger. They're kind of limited in terms of what they can do with the ARM core because it's a new Cortex-A8 processor. But yeah, I mean, if you want to debug the machine at that level, if you use the official tools, they'll actually tell you cycle by cycle, like trace, instruction by instruction, what the CPU is doing in real time, what the DSP is doing, peripherals are doing, and so on. It's extremely sophisticated.
Can you flash it through the USB port?
Yes, you can.
Can you also flash it through the USB?
Yes, you can. It's actually unbrickable because no matter how bad you screw it up, there's a button you can hold down on startup, and the boot ROM will not look at anything and go straight to the SD card and read everything off a standard FAT file system. So you can never completely ruin it unless you put too much voltage into it or something like that. So these are some different ways to use a BeagleBoard. One way is to use it like a desktop PC, and this is actually how I'm using it. I have a USB hub attached to different devices. I have an SD card with my OS. This is basically like my hard disk, right? And I have power plugged into this power jack. And I occasionally use monitors for output and like development. This guy's actually using it as like a real PC. He's running a window manager and all of that stuff. And like I say, it's equivalent to like a Pentium 3 from maybe like 8 or 9 years ago. So it's more than enough to run a lot of desktop applications. There's a variety of operating systems you can use. Angstrom is the most popular, and it's community supported, and I think everyone I talk to here is using Angstrom right now. But you can also run Windows embedded, and that costs money, so I haven't been able to experiment with it myself. A lot of people are developing with Google Android apps on the BeagleBoard, and one neat thing about that is that Google Android actually has a great UI if you've got a keyboard and mouse. It was like a total surprise to me because it's a cell phone operating system, but it's quite usable. Nokia is developing a new OS called Nemo 5, and they're developing it on the BeagleBoard. So a big part of the community is working along on their BeagleBoards with this because Nokia intends to release new phones and tablets based on the OMAP 3 that's on the BeagleBoard. They're sort of using this to do their development. Also Ubuntu, which is the operating system that couldn't talk to the projector earlier. You could also get that on your...
Nathan, before you go,
Sure,
let's go back
absolutely,
to that previous slide.
Yeah.
You start out and you're going to put an operating system on the SD card.
Yes.
And if you use this as a desktop environment, that also becomes sort of your hard drive.
That's correct, and that's how I'm using it on this robot,
Okay.
yeah.
The question is, at some point, let's say you have a 2 gigabyte SD card and you filled it up. It's probably going to be somewhat painful
Yes,
to
it
strip
is.
everything off. So would you suggest getting the largest
Yes.
capacity SD card and living with
Yeah,
that?
don't go crazy. I mean, there are actually 64 meg cards out now, but I mean, I'm using an 8 gig, and that's
Yeah, 8
plenty.
gig would be
Yeah,
more
and
than
it's
enough.
like $20, so it's whatever, no problem.
And I think the other thing to think about though on the Beagle is if you're using it as a USB host with a pub, you could just plug in any additional thumb drive as well.
Yep, that's absolutely
So
correct.
It's not just your SD
You could
card,
plug in
you
a
can plug in
it's-
thumb drive.
Yeah, you can plug in a
terabyte.
terabyte hard drive if you want. People have done that. That works too. So go ahead.
And can you go back that one thing?
Oh, sure,
So how do
absolutely.
you,
Yeah.
so to load the OS on, you go in through the USB port? Is that
No,
essentially-
you can actually just copy it onto the SD card.
So there's enough on there that you could be able to say,
Oh, yeah.
initialize the SD
It
card?
boots off the SD card as if it were a hard disk. It treats it exactly like a hard disk in a regular PC.
So they're just images on the web and you just
Yes.
download and just copy right
Yep.
DD to it?
Yes, that's exactly right. In fact, with John's help, we actually created a DD image of Snappy software,
Got it.
and that has some special support for OpenCV and cameras and some other vision processing stuff that you could use if you wanted to bootstrap a robot.
Just one thing I'd add is to create the SD card, to make it bootable with a Linux-based operating system, you really need a Linux desktop to work from.
Right. Although if you use DD, you don't.
For DD,
DD is something you can download for Windows, and actually, John was able to get it up and running. I mean, it was a few
it will replace
steps.
the XE2
That's exactly what it
He was
does.
a young man.
DD
Yes.
is actually,
Yeah.
DD is actually a Linux, or originally was a Unix-based tool to do
Yep.
a byte-by-bit, or actually a bit-by-bit
Yep.
copy from one source to another.
That's exactly what it does. So it writes the file
ported
system
over to
structures,
Windows,
all
it's
of
going
that.
to do the same thing, and you can take an image that is, I've done this repeatedly, where you take an image of like a Windows system mounted under Linux,
Yep.
DD it, and you will get, including the boot block.
Right. So needless to say, even if you're a Windows user, you don't have to install Linux, although I think having some Unix background will help, because eventually you're going to be faced with a command prompt, since the BeagleBoard does run Linux, right? And so having a little bit of command line experience would definitely help. The other way you can run it, if as not as a desktop device, you can also run it as an embedded device. And this is more similar to what Tony is doing right now, although I think he's going to try and build it into a more able system with cameras and all of that. But I hadn't seen this done before until I went over and saw Tony's robot, but basically he's only using one connection. He's using the USB device connection, and that's providing both power to run the BeagleBoard, and it's also providing his debug cable so he can plug it into a PC. And the way he's got this set up is this appears as a network adapter to his operating system on the laptop. So the laptop thinks you plugged in a network adapter plugged to some network. And what it is it's the BeagleBoard. And so you hook up your network, and it has internet, and you can telnet into it and control it and run the web browser and all of that. And that's actually how he's been doing all of his debugging and development on the BeagleBoard. So this is a very, very simple way to do it. You just need one cable and BeagleBoard. Sorry, go ahead.
USB also serves as the computer can also serve as a router. So if
Yeah.
you want to download stuff directly to the BeagleBoard, that's helpful.
Right, right. So in other words, you want to do a software update on the BeagleBoard. And I mean, this is running like a real operating system. It's not stripped down or anything, so you can run a software update and get all the latest bug fixes and everything just like that over the internet on the BeagleBoard. So there's some ways to do this. You can use Angstrom embedded. OpenWRT is now supports the BeagleBoard, and I know we have some experience with that in this club. So some other Linux robots around here have used OpenWRT before. Debian has now been ported, and if you're really, really brave, I guess is the word, there are some people doing bare metal development on top of the OMAP 3, and you know, it's just like any other microcontroller at that point, except it has 2.4 gigaflops at its disposal, and you know, 4,000 pages of technical reference material. But people are doing that too and sharing their source code. So one of the great things about the BeagleBoard is there's a really big community. I've been having a lot of fun. I have to warn you, it can be a little bit of a time sink just because you'll have so much fun interacting with people and talking about projects that you'll forget you actually need to finish your projects. But there actually are over 1,000 people, 1,000 different people have posted on the mailing list. And so who knows how many people are actually like playing along at home, right? These are just 1,000 people who've participated in some way in the community. Obviously it's cheap, so a lot of people have it now. TI has been great about the hardware documentation. They released the Gerbers and the Eagle CAD files and everything to the board itself to try and encourage people to make their own boards. And so people have been using the Gerbers to fix bugs in the hardware or solder interesting things on to different solder points and things like that. So if you wanted to build a daughter board or something like that, you could have access to the schematics and see exactly what you need to do. The other thing is that, of course, there's a lot of code, and it's all open source, 100%, you know, like GPL sort of stuff. And probably the best feature, in my opinion, is the IRC channel. Because whenever I run into some stupid problem, I can go onto the IRC channel and say, this is what I've got. And one of the hundreds of people idling there will snap up in 5 minutes and say, this is what you do. And I'm up and running. So, all right. So why should you build a BeagleBot? One reason is that I think Linux plus robots is sort of a winning formula in the hobby community. And, you know, I have one of our members right here with, I think, one of the first Linux-based robots that really caught on at the club, and I know Brandon has built one of these, but this is just a Linux router and Linux operating system running it. You know, there are books on this now that are, also, you know, there are pre-made kits like this Turk kit from CMU that's all Linux-based. And so one of the great things about working with Linux on a robot is that Linux has this philosophy of sharing. And so it's really easy to find people's source code and find people on a forum and ask them questions and all of that. And the community is actually very friendly if you know what you're doing. I mean, if you ask dumb questions, then you can get some like hilarious responses. But you know, it's actually very easy to find a lot of help if you're building a Linux-based robot. So, which I think is a benefit. Another reason to build this is, or build a BeagleBot, is the OMAP 3. This thing's already cheap. I mean, like I say, the thing has like all that stuff packed into a chip, which is like $70 in quantity one. And who knows how cheap, you know, if you're mass producing
I
it.
think it's $50, isn't it now?
Oh, is it now 50? Yeah, it doesn't surprise me.
And the other thing is 50 is for the high-end
Yeah.
Ferrari chip.
Right.
There's a graphics, it's almost like what would be a graphics card
Yes.
is on that chip. There's a version of the chip without the so-called
Yep.
high-performance graphic
Yep.
card that's $40.
Yep.
And there's one that if you can get rid of the high-end floating point, it's $30.
Right. And so, yeah, absolutely. And so the great thing is this is a complete system on a chip that's PC-like, that's very, very cheap. The price is getting really small because there's hundreds of devices that are going to use it. And there's becoming a commercial community around this. So there's already people building really good tools to help support it. One of the, I'll show you some examples of products that are using it right now. I love this thing. This actually just started shipping. It's a community effort called the Pandora. That's an EPC that's next to it. So you can kind of see like how little battery power you need and how little size you need to have like a QWERTY, you know, computer, you know, and I don't even know, this isn't even a netbook, I don't know what you call it, but it's a little clamshell based on the OMAP 3. There's a new product from Arcos called the Arcos 5, which is based on the OMAP 3. The new G phone, HTC was showing off this thing running Google Android, and it's based on the OMAP 3 too. Also, Nokia is making some products. No one knows exactly what they're going to be, but we're thinking it'll be like the Nokia N800 series tablets. Next year, they're going to be based around the OMAP 3. All we know is that they've been porting like crazy to the OMAP 3 kernels, so they're very invested. Also, there's OMAP 3 boards. So if you're like me and you want to use a board, well, you can go out and get a Gumstix Overo. And this board is available now. It's $149 like the BeagleBoard. It's different than the BeagleBoard, and I'll describe why later. But you know, if you're building something really small and you need a lot of computing power, well, there's the OMAP 3. There's a combo Bluetooth Wi-Fi chip, and there's a micro SD slot that you can put 8 gigs into. And it's literally smaller than a stick of gum for the whole thing. This is an open source board from OpenPandora, which is a little bit more PC-like. It has more USB ports and more SD card slots and all of that. It's in the same price range. And then this guy is Magneal, and he's actually just developing his own sort of inexpensive 4-layer board that anyone can produce. And it's, you know, so it's a little bit simpler than these other ones, but it's also a design you could take and actually build on if you wanted to actually produce your own boards based on these chips. So I've already talked a lot about this, so I'll sort of speed through this, but ease of development is a big reason to use the BeagleBoard. If you're used to microcontrollers and things like that, GCC and GDB, the ability to inspect variables and set breakpoints and really work with your system interactively is nice to have. Also, you can use high-level scripting languages like Python. You can also use languages like Java with IDEs like Eclipse. And of course, since this is Linux, there's literally hundreds of different languages. I mean, if you like Lisp, there's a dozen implementations. You like Forth, a dozen implementations, it's no problem. Also, you can run these complete robot SDKs. There's this thing called Pyro, which I quite like. It stands for Python Robotics, and it's a very simple stack that's designed to help you write robot control in Python. But what's cool about it is it includes all these modules for things like localization and mapping and path planning and the kind of stuff that is literally implemented in hundreds of thousands of lines of C code. And you can just put a little Python bit on the top and say, hey, go over here. And you don't have to sit there and like invent all of this functionality like you would otherwise. Player Stage is in the same sort of camp. Actually, Pyro borrows from Player Stage. But this is an open source research community operating system designed by some guys that Tony works with at Willow Garage to help seed sort of the open source community. And I mentioned before that you can't brick the BeagleBoard no matter how much you screw it up. Being able to debug is really useful too. I found that being able to do remote debugging via Wi-Fi is very nice because I can send things like images from my cameras and update large bodies of code and things like that, all without stopping the robot. You can just sit there and run. Oh, sorry, go ahead.
You're getting the Wi-Fi through the USB?
Yes, I am. On this board I am. And I just have a little hub on the back of my robot. It's about this big. This was $9 at Fry's, and you can get something like this and just plug it in and then have 4 devices.
Is it, another quick question, is
Sure.
that high-speed USB? Or?
It is, yes, and I'll cover that in a minute. The other thing is that you can get video output, which I showed you before, which is great for debugging. And you can basically log like almost infinite data. Like for a little while, when I was trying to tune my balancing algorithm, I really wanted to record like every single run I made to see exactly why it was failing. And I was taking all kinds of information out of the inner loop at 1 kilohertz, and that included variables like the state space and the information inside the Kalman filter and all the PID controls and all of those different values, all the raw sensor readings. And you can do this all day. You can store 8 megabytes per second and the BeagleBoard doesn't hiccup. It's no problem. It doesn't lose a byte. You could even store uncompressed video from your camera, and that's no problem, right? Or if you don't have such crazy needs, you can easily fill up the cart with like every run your robot ever makes over years and years. So it's quite useful for debugging that kind of information. Now this is just something I thought was really cute. As an example of ease of development, Dale Wheat from the Dallas Club was telling me about his Beagle Bot, and basically what he realized was the BeagleBoard fits right on top of Pololo's 3 Pi. It's like exactly the same dimensions. And so what he did was, he'd been working on the 3 Pi for a while, but now he can log data from his runs while he's running the thing around, And he can also like wirelessly log in and upload new code and check it out. And he's thinking of maybe moving new functions up onto the BeagleBoard so he can have higher level control written in scripting languages and things like that. So it's actually like really speeding up his development versus plugging in the, you know, serial connector, turning off the robot, you know, doing all that stuff every time. So peripheral support. USB peripherals are great. I love using them. You can get every kind of USB peripheral. They're cheap. You can go down to Fry's and find 1,000 different varieties of whatever you're looking for. They're low power because USB can only source 2.5 watts, and most of these peripherals are designed for laptops anyway. So actually USB is really a great way to get robot parts. One thing that I like about it is it's very noise resistant. In the kinds of distances you have on a mobile robot, like a few feet, the USB shielding and twisted pair implementation is quite clean. It's a lot better than something like RS-232 or whatever. And I would say that, I mean, it also has integrated error correction, all of that stuff, so you don't have to worry about the usual issues. Often it's better than kits or modules. Like, this is a $60 camera, which I really like. And, you know, it has very good optics, and it also has autofocus, and it also has manual focus you can override from your code. So if you have a robot that has some way of gathering depth information and it wants to get a picture of something it knows the depth of, you can manually override the focus and say focus this on this object, you know, at this depth, and get an extremely clear picture. And if you buy a $60 camera module, you know, that's not like a mass-produced USB like that thing like this, there's no way you get this level of functionality. So you can often do better than kits or modules. Also, you can run up to 16 devices at 480 megabits per second. And Linux literally has thousands of drivers, so just about everything you buy at Fry's, you can get working with Linux. So. Also, a lot of these interface modules that are designed for building robots and other things have USB ports now. So if you're building a robot from scratch and you've decided you want to use the BeagleBoard in it, you don't have to go to the trouble of like figuring out how you're going to interface the high level to the low level. You can get one of these pre-baked solutions that's got a USB port and, you know, high voltage I/O, servo, you know, maybe some local processing, whatever, and plug it directly into your BeagleBoard. And a lot of these things have native Linux support, so you can get the drivers right the way you need them on the BeagleBoard. Code reuse is another big reason. This is almost a joke slide, but these are just some of the things I found open source packages for, and most of them, like computer vision, there's like 10 options. And so if you really don't want to do it all yourself, but you want to build a capable robot, then there's an opportunity to go out there and sort of sift through what other people have already done and get started. And all of this is Linux based, and so it'll just run on the BeagleBoard. You run make, like OpenCV. I thought there would be some porting effort or something. No, you just pick it up, you type make, you know, 20 minutes later, your BeagleBoard has OpenCV. So
You did all the building right directly on the BeagleBoard.
absolutely, why not? It's a computer, right? So yeah. Although in some cases I do some cross compilation just because it's faster, but yeah, a lot of stuff I can file right on. So there's the ROS project too. And I just wanted to mention this because Tony's been talking about how he has access to ROS code, which is being developed at Willow Garage. And,
Everybody does.
yeah, everybody does because it's open source. He has access to the guys who can explain it, which is useful. But what Willow Garage is creating, they're calling it the robot operating system. You know, I mean, they're obviously pretty crazy about this, but it's a Linux-based distro, sort of like Debian or something like that was a Linux distro packaging all this software. They're taking all the best open source robot software, they're cleaning it up, wrapping it so you can use a common API, and then it becomes swappable. So like OpenCV isn't working quite right for you, you want to use EmbedCV, that's fine, it swaps under a common API. This path planning doesn't work for you, but someone wrote a paper and an implementation you want to use, you swap it out. And this is being tested on real robots, actually. There were demos at RoboDev sort of showing what this stuff is capable of. And of course, Tony thinks he might get a line or two from Ross into his Robo-Magellan bot eventually. And these are just some of my favorites. These are things, open source stuff I'm using. I'm using the Kinematics and Dynamic library, and it helps me give a three-dimensional location for my arm and have it do the path planning automatically, so it prevents the arm from doing stupid things like running into itself or running into the other arm. All I had to do was provide a config file, and it did all my inverse kinematics for me. And the config file is like 10 lines of XML saying this joint is this long and it connects to that joint, which is that long, and so on. OpenCV, of course, we've been over. It does all kinds of great stuff, and it's free. But if you're trying to do stereo stuff, there's this thing I found called the Surveyor Stereo Vision System, and it's designed to run on these black fins. It's written in C code, and it's actually quite efficient, and it works really well on a more powerful processor. I mean, the ARM is much more powerful than the black fin, or well, the ARM in the BeagleBoard. And so, you know, you can use webcams as inputs to this software and actually get near real-time performance out of it. I mentioned Player Stage, which I use. It's great. And also, I found this thing called Embed CV, and it's a lot easier to understand than OpenCV. I mean, OpenCV needs a book, and it's a good book. You should go get it. But Embed CV, you can actually get working with it right away because it's much more limited in scope. But it's very focused on the kinds of things you need to do in a robot, like color segmentation and, you know, edge detection and object tracking and that sort of stuff. It's really nice. And it's optimized for ARM, which doesn't hurt.
Are there efforts to optimize OpenCV for this environment?
Well, I don't know what you mean by effort. I mean, there's talk on the forums, and I've seen one of the things about that you can do with OpenCV is that it's got a really good split between like the logical implementations and the kernel layers, and some of the kernel layers are very would fit very well on a DSP. And so there's been some talk of taking specific kernel modules from OpenCV, moving them to the DSP, and that could result in great performance, but I haven't seen any code yet. So, so I just wanted to say this is like my favorite example of telepresence. This guy, code reuse. This guy built a telepresence robot, which is something I think is really cool, and I think we have one tonight. But he used Skype, and it's like, what a great thing. You know, you have Skype. It's already available for Linux. You know, it's already available for every operating system. People can connect into this thing and have a great UI and have a great conversation through your robot, and you did zero work, right? And that's the sort of thing that the BeagleBoard lets you do, is just take a commercial or a free application and just, very little work. And so the performance per watt, which we discussed, this is actually a little bit more specific. And I did some analysis after I shattered Snappy to try and decide what I wanted to do next. I looked at Blackfin, and Blackfin is actually great power consumption. One of the downsides is there's no floating point, and that can be useful. I thought maybe I'll want to grow into that. Ironically, I only use integer right now, but you know, whatever. Sorry, go ahead.
Yeah, actually, I think you'll find that Blackfin is more like 2.4 Gmax.
Oh, is it?
600 megahertz.
Oh,
it's
yeah.
got,
See, I thought it only had 2 multipliers.
I think it's got. Okay, maybe it's 1.2.
But still, right? Yeah. So sorry, I got it wrong.
There's one flavor of it that's got 4.
Right. Okay. And I was looking at a very specific board that ran at 500 megahertz. So you're right. I should have been more specific about what board I was talking about. And I'm not pretending to be an expert. I'm just an enthusiast.
Another problem with the Blackfin that has no MMU, so you're forced to use a
UC Linux. And UC Linux is not that compatible.
It's really
with
going to
Linux.
throw the monkey wrench in getting software ported.
Absolutely. And so that's a limitation. The BeagleBoard, of course, I like. At peak, it's 2 watts. At idle, it's 1 watt. Actually, the OMAP 3 is even less power than that. And one of the reasons the BeagleBoard takes as much power as it does is because it's got things like the DVI chip and all of that other stuff. Well, they're adding support to the kernel to power those off now, so it should get even lower power than that. But of course, it just sips power at a watt. I looked at Atom boards, and I want to love Atom because the CPUs are quite good, but the chipset still has a way to go. I mean, I've actually seen Atom boards where there's like a little tiny chunk of aluminum on top of the Atom chip, and then the chipset's got a giant like smokestack size filter. And so this is actually the most power efficient Atom board I could find, and it's still 5 watts at idle. So, and as you can see, in terms of raw performance, the Atom is actually somewhat similar to the BeagleBoard, and that's just because it's a basic in-order implementation like the BeagleBoard. At least the BeagleBoard is dual issue, so it gets better performance relative to the Atom. And then just for fun, I put a Core 2 Duo on there. If you're building a serious robot that has battery for that, you actually get quite good performance per watt. Better than Atom, but it has to be a big robot. So, And the other thing I wanted to mention is that one nice thing about the BeagleBoard is that the DSP adds some bonus Macs for you. So yeah, if you want to run the DSP in parallel with the ARM, then you get all this like free processing power you wouldn't get. And it'll actually do twice as many 8-bit multiplies as it will 16-bit multiplies. So you can get all the way up to about 7 billion multiply accumulates per second if you're doing like 8-bit pixel operations. So it's all under 2 watts too. So this is just an example of what you could do hypothetically with the BeagleBoard. Is it's actually possible to run up to 2 USB cameras at 800 by 600 by 25 in frames per second in raw mode. The bus has just enough capacity for that, and that includes all the overhead. You can then, what's interesting about this is it has special onboard buses, and I sort of drew a line through here to indicate how it works. But without going to main memory, you can directly access the information streaming through your cameras through your USB by the DSP. So you can set up a streaming kernel and not even touch main memory, just use the onboard buses. You can then send the integer data out to the FPU for some sort of floating point processing. Maybe you're doing higher level stuff like object recognition, which almost always uses floating point. And you don't waste any bandwidth. You don't actually have to even touch memory at that point. So having everything on chip like this, from the USB controller to the DSP to the ARM, is really nice because you can use those on-chip buses. The DSP is programmed in C, and I actually have a couple little sample programs I can put online, but that basically just copy data in and out of the DSP. The TI compiler is free, but only if you use the, or only if you release your code as open source. If you're trying to do a commercial project, they still want you to buy their products, so whatever. Anyway, needless to say, the OMAP 3 is very fast, and actually I discovered a bunch of people on the IRC channel who had been using the CMU cams, and they're porting the custom code they had written for CMU Cam 3 over to the Beagle, and it immediately runs at 16 times the resolution and 4 times the frame rate or something like that. It's just substantially more powerful ARM processor than what you had on CMU Cam 3. So yeah, the final portion of this talk is just how to add the BeagleBoard to your bot. One thing that's really important is the power input is super sensitive. So you really should be at 5.0 volts if you can avoid it. You probably can't use battery power just because it's so specific in its requirement. You also need a USB hub that has a power input. What's interesting is a lot of USB hubs don't come with a power adapter, but then they've got like a little tiny port on the bottom like this. And basically everyone I've ever bought has this little tiny port. What this is for is to run 5 volts into. So once your robot has 5 volts, you run 5 volts into your BeagleBoard, you run 5 volts into your USB hub, and then you have a powering system. That's about what the power is. It's about 400 milliamps, 2 watts. About up to 500 milliamps per USB device. I found the cameras use like 150. Wi-Fi can use up to 300 depending on how much you're transferring. You should think about using a battery elimination circuit. If you know how to design your own regulators, then go nuts, but I don't. And one of the things I like about these BECs is that you can go down to like Aero Micro on El Camino or something like that. They have these for $25, and they'll give you 5 amps, and they have really efficient, really clean buck converters in them. So you get very high efficiency, very quiet power. And one of the reasons it's so quiet, of course, is that in a model airplane, the further off you get, the more the noise going into your receiver will actually affect your range, right? And so these guys do a really good job at getting completely quiet output. And it's so well insulated from the motors, I'm down to 1 battery now. So I run all this USB stuff and everything side by side with my noisy motors through the BEC, and it completely cleans it up. It's like flat on the oscilloscope. Go ahead.
What kind of battery are you using?
I'm using a lithium polymer battery. So
just something you got at Air Micro?
the battery itself I actually got at a place called Tenergy. So, and I can post more detail on the mailing list about that if you want. So to actually talk to your robot, you can use a TTL UART. There's a bunch of these things. This is actually one of my favorites, I think. Or I think Brandon introduced it to me, but basically it's got TTL UART on that end and USB on that end. So this is just like cables you can get on FTDI's website. Or you can just use a level shifter. And I never saw this done before until Tony did it, but it's great. Basically, he just picked that port, ran it through a little level shifter like this, and he was in business. He had his PICs talking to his BeagleBoard bidirectionally. Also, I thought it was interesting. I know Ralph has a much better solution to this, but there's this thing called the Brew Stick that has drivers and SCI support and all of that. And you plug it into USB on one end and your Roomba on the other end, and you're done, right? So buy a Roomba, buy the Brew Stick, buy a BeagleBoard, you have a working robot. So if you're building a new robot, I have a couple of things which I think are cool. There are probably cooler things out here, but it's got some high voltage DC motor controllers, or it can do steppers. It also has servo controllers and analog to digital converters. But what I thought was neat is it speaks this thing called OSC. And this is actually an open protocol for sound control. And so it's like MIDI 2.0 basically, right? And so every language I looked at anyway, from Python to JavaScript to C to Java, had an OSC stack in it already. And so you could literally just go get one of these make controllers, plug it right into your BeagleBoard, use the language of your choice with an OSC library, and immediately start telling your motors to move and reading encoder information back and all of that, because the default firmware in that handles all of that. And actually, Willow uses the make controller on his robot. So you can actually kind of show you what it's like.
Yeah,
later.
I've got it right over here.
Right, so during show and tell you can sort of give people a look at what that's like. And so also if you want, well the community is very robot friendly, so you can go online and get help from them. But also you can run custom firmware if you want, and Willow has actually done that. So part of his robot's logic actually runs inside the make controller, which is handy. Arduino, it's the same thing. This also has a very large community. I can't believe how many people know about Arduino. It actually speaks MIDI over USB. Again, MIDI is supported in all languages. You can run custom firmware if you want. What's really cool about Arduino is it's got this daughter board thing. So you can get like motor controllers or encoder readers or sonar sensors or whatever. A bunch of things just stack on top of this daughter board. And I think it's actually like a great little platform for building like a robot stack. So. Also, if you want, you can go to the BeagleBoard routing hack, and this is just everything I've told you before, except one thing that's nice about this is that all these features are now working in user mode with the latest kernel. So you can actually just write standard C code and talk I2C or UART or GPIO or whatever over this bus. Also, there's daughter boards maybe in the works. Someone's talking about a GPIO level conversion. Somebody else wants to put an Atmega servo controller that can mount on this, and he's on the forums, and so maybe that'll come along. Dave's talked about ideas that seem pretty feasible, but I haven't actually seen one yet. So, one nice thing is that you can use these LEDs for status, and I've started doing that now. When my robot is running, it blinks the little LED on the BeagleBoard to tell me it hasn't crashed, which is very useful feedback.
Has it crashed?
It has?
No.
Oh, whew, thank you. Well, it wouldn't surprise me. It happens.
Just curious, do you know how fast you can toggle the GPIO?
Well, it just depends on the code. I mean, one of the problems, well, what you would probably want to use is the DSP, because the DSP has access to all the peripherals that the ARM does, but the DSP has guaranteed latency, whereas the ARM, it's like a real CPU. I mean, it's got cache misses and TLB misses and all this other stuff. So if you wanted to do some real-time bit banging, then yeah, the DSP could update the GPIO at like 200 megahertz. So.
Have people talked about putting the real-time extensions to
Yes, in fact, it is working. I haven't tried it myself, but some guys are using it now on the BeagleBoard. And apparently on the BeagleBoard, you can get real-time control down to something like 20 microseconds. So it's still a little noisy, but it's not bad. All right, and so if you really want to go crazy, these guys are working on the ZinBot. And I thought this was really an interesting picture. And they actually developed a custom board to mate to the Gumstix. And they're using a Gumstix Overo now. So they're actually building these humanoid robots for something. I think it's soccer. Pretty sure it's soccer. And so it needs to be lightweight, it needs to be low power. This thing is tiny. I mean, again, that's like the width of a stick of gum right there. So they built a custom board and all of that. One of the cool, oh, sorry, go ahead. Okay. One of the cool things they're doing is they're actually giving some of the information back. So if you wanted to build boards like this, they're actually releasing some of their code. So yeah, the Gumstix Overo. I just mentioned it a few times. I want to mention it one more time. It's a little more expensive, even though the Gumstick is $149. You have to pay an extra $60 for this board. Without this board, it's almost useless because it has these little tiny 70-pin connectors on the back that are really, really hard to work with. And I mean, the 70-pin connector goes from here to here, which is under an inch, and it's a lot of pins. But it's cool because even with the expansion module, it's half the size of a BeagleBoard. So it could be useful for some people. It also has more RAM. It has 256 megs. It also has Bluetooth and Wi-Fi. It has micro SD, which should be okay unless you need SDIO. It doesn't have S-Video, it doesn't have RS-232, but the real limitation is there's no DSP and there's no 3D graphics score. And that's what John was alluding to earlier. There's different versions of this chip that are missing features and they're using the cheaper version. So gotchas, just really briefly, make sure to order the right stuff, get the right serial cable, get a hub that's got one of these little things, you know, so you can send power to it, and get the right USB Mini A host cable. The first time I bought my BeagleBoard, this screen popped up which says, hey, would you like to buy these things? And I just ignored it because I always ignore these things. When you see this screen, stop and say, hey, wait, someone told me I should go find the cables I need, because if you don't find the cables you need, you're going to be driving around all over the place trying to find them because they're kind of rare. So the other thing is use the right kernel. There's a bunch of demo images online which have these old kernels with buggy USB. You got to have the newer kernel. Also, there are some kernels out there that people have built really stripped down, so you'll plug in your Wi-Fi and say, hey, this doesn't work. Well, it could work if the kernel was built right. Obviously, you can build your own kernels if you have experience doing that. And also be very careful with the power supply, because I did see at least one BeagleBoard let out the magic smoke because of the power supply. It's really, really sensitive. So, all right. Also, final word is there's this thing called Revision C, and a lot of people are using it as an excuse not to get a BeagleBoard right now. It's not that great. It's not out until February. We get one more USB port, you know, but you use a hub anyway, so you probably don't need it. It adds these LCD controller pads, which are like so tiny you can barely see them. You're probably not going to be using them for anything. It has minor bug fixes in the OMAP 3, but there aren't really any bugs that haven't been worked around in the kernel. They might have a version with more RAM, 256 megs. One thing I've learned is that SD cards are great for swap because there's no seek time. They have I/O speeds in excess of 25 megabytes a second. And so I actually run some very large applications, you know, and very big builds and all of that stuff swapping to SD, and it's perfectly fast. So anyway, otherwise it's identical. So if you design something around the BeagleBoard Rev B when the Rev C comes out, you know, it'll work.
Are you worried about the write time cycle limit from SD card using it as a swap device?
Not really, because SD cards have wear leveling integrated into the card, so it's not the same as using a raw flash chip for swap, which would be really bad. You could definitely kill it faster than that. All right, so anyway, these are just references. If you go find the slides online, and they will be online, then you can go and use these. Obviously, the only one you really need to remember is beagleboard.org. If you decide to buy one, you can go there. It's a great reference. It's where all the research stuff is. You can purchase and all of that. And my final word is, if you do something with the BeagleBoard, go subscribe to the mailing list and tell us about it. And also ask questions, because I love answering questions about the BeagleBoard. And I'd rather you send them to the list so everyone gets to see the answers, and maybe it makes it into the wiki and so on. So definitely, if you haven't gone to the HB Robotics list, go sign up now. We've had a lot of BeagleBoard talk already. I mean, I saw this, just one second, I saw this really cool Iron Man costume on Google Reader a while back, and I had no idea that was being developed by someone here in the Bay Area. So that's the kind of stuff I want to hear about on the list. And anyway, so that's it. Can't wait to see more BeagleBots. Thank you.
No more questions?
And you can always come see me after the rest of the show and tell and ask me some questions.
I'm just curious, how many people remember, I don't know, it was 2-3 years ago, I gave a Linux talk. Anybody remember that talk? Yeah, okay. If you recall, my premise was that Linux was sort of going to make it big time in robots. I think we can say that it's happened. Okay, so
What?
Yeah, forget the robots.
Yeah. So, okay, we're now going to do the show and tell portion.